Hi, everyone. This is part two of a three-part expansion on the whole idea of simplifying radicals. Today, we're going to look at addition and subtraction, multiplying of radicals, and then also we're going to look at some uh, ideas on how to divide out by two terms with radicals. Okay, so let's do a screen share here. Here we go. And so when we look at this, we did the first page yesterday. So this is getting on to the second page. So here we're adding and subtracting radicals. The idea with adding and subtracting radicals is very similar to combining like terms. The number in front of the radical changes, what's inside the radical does not. You also have to have what's called like radicals. So not only does the index have to be the same, but also the number underneath has to be the same. So the first step we do when we add or subtract radicals is we actually simplify as much as we can. We pull out any perfect squares and we simplify the variable part as much as we can. Similar to what we learned yesterday. And so this first example, we have this 3 square root of 2 minus the square root of 8. And so the square root of 2 part, that's simplified as much as possible. The square root of 8, that's not like the square root of 2 yet. So we couldn't subtract them yet. But let's look at the 8. There's a perfect square with 8, and it's 4. So we'll write the 8 as 4 times 2. So writing the 8 as 4 times 2 underneath the square root, we can take the square root of the 4 and get 2. So that gives us 3 square root of 2 minus 2 from that square root of 4 part, square root of 2. These now are like radicals. So we can take the 3 minus 2, which will give us 1, and that gives us 1 square root of 2, or just square root of 2. Let's take a look at number 2. So in number 2, we have 3 square root of 18 plus square root of 27. Again, can't do anything with those yet. They're not like radicals yet. So we simplify. The 18 is 9 times 2. We pick 9 because it's a perfect square. Take the square root of 9 and we get 3. So that gives us this 3 times 3 here, which would be 9. Times the square root of 2, you can't do anything with. And then the square root of 27, 9 times 3, because again, the 9 is a perfect square. I take the square root of the 9, we get 3. And the square root of the 3, that part stays back. So these are not like terms, like radicals. So that's the farthest we can go. That's it. Okay. When we have variables, no big deal. It's the same idea. We simplify when we have variables. So this first part, this 3x square, 3x to the third times the square root of x. Can't do anything with square root of x. The exponent for x is smaller than the index of 2. However, the next one, the square root of x to the 7th, we can do something with that because the 7's bigger than the index of 2. We have to simplify. Now, what's that rule if it's even, like with a square root or a fourth root? We write the odd power as the next lowest even number times x to the first. So that'd be x to the 6 times x. And then we divide out the 6 with the index of 2 and get 3. So we have an x cubed outside. And then we have that square root of x still there. So now these are not only like radicals, but the x cubes are like terms. So we can add the whole thing together and get 4x to the third because of the 3x cubed plus the 1x cubed, and then the square root of x. When we multiply, okay, if you have 2 terms times 2 terms, really it's just like that FOIL process. You just distribute through. If you have multiplying 2 things that are square roots, you can multiply the stuff underneath the square root together. If they're not like radicals, you can't combine them. So this adds a layer to what we just learned. So we distribute or FOIL out. 1 times 2 gives us a 2. 1 times root 5 gives us the root 5. Minus 3 times 2 gives us minus 2 square root of 3. And minus square root of 3 times square root of 5 gives us minus square root of 3 times 5, or 15. None of those are like radicals. None of them can be combined. We're set. That's the furthest we can go. For this one, we have the square root of 2 minus 3 and the square root of 2 plus 3. Okay? So we distribute. Square root of 2 times square root of 2 is square root of 4. That'll give us a 2. Square root of 2 times 3 is plus square root of 3, or plus 3 square root of 2 rather, minus 3 square root of 2 is minus 3 square root of 2. So these two are like radicals, and they have opposite signs with the same thing in front. So those two are going to subtract out. And then lastly, the minus 3 times the positive 3 gives us minus 9. So we can actually end up adding the 2 and the minus 9 together, giving us minus 7. When we have something like a quantity squared, don't forget that that's like repeating what's in the parentheses twice and then foiling out. So x times x gives us x squared. X times square root of 2 gives us x square root of 2. Square root of 2 times x gives us x square root of 2 again. And square root of 2 times square root of 2 gives us the square root of 4, which ultimately gives us this 2. So we have an x squared and a 2. And then these two parts, unlike the previous example, these two parts, they add up. They're like radicals. And also the x's in front are like terms. So we can completely add them together and get 2x square root of 2. And then for this one's messy, okay, because we have some coefficients out front of the radical. Okay. When we multiply these together, we'll multiply the 3 and the 2, giving us 6. And since the 5 and the 2 here are underneath the radical, we can multiply them together, giving us the square root of 10. You really can't do anything with the square root of 10. There's no perfect square there other than 1. Then we have the square root of 2, or 2 rather, square root of 5 times minus square root of 2x. Again, same idea. I multiply the 2 with the minus 1 in front of here. That gives us minus 2. And I multiply the 5 and the 2x together, giving us 10x underneath the square root. And again, there's nothing we can do with that. Multiplying the minus square root of x. There should actually be a 2x here. Sorry about that. So we have the square root of, or minus the square root of x times 3 square root of 2. And so that gives us minus 3. And then there should be a 2 in front of the x underneath the square root. So we might want to adjust that and write it as square root of 2x. Okay, sorry about that. And then we have minus square root of x times minus the square root of 2x. So that's going to be a positive, minus times a minus. And then 2 times x squared. Well, what can we do with the x squared? The index and the exponent are the same, so that means we can divide them out. So 2 divided by 2 gives us 1 outside of the radical, so we end up with an x outside the radical in the square root of 2. So our final answer would be 6 square root of 10 minus 2 square root of 10x minus 3 square root of 2x. There should be, again, a 2 in front of that x, plus x square root of 2. When we're dividing by 2 terms, unlike what we learned about yesterday where we had 1 term, okay, we just multiply top and bottom by that square root. In this case, we have 2 terms. We're adding or subtracting 2 things. We think about example number 2 up here. In number 2, it got rid of the square root. We're going to do the same thing with this. So in other words, look at how those 2 multiplied out. We had a minus in between and a plus in between, the same 2 numbers. Those are called conjugates. Okay? And on the handout I gave you earlier, I sent out to you earlier, it did talk about that some too. Okay? That should be in your D2L site from a couple of days ago. So we start out with a 1 plus square root of 7. Now 1 plus square root of 7 has a conjugate of 1 minus square root of 7. Again, whatever's in between the 2 here, you do the opposite of in between the 2 here, over here. Okay? So if this was minus, this would be plus. If this is plus, this part's minus. Okay? And we multiply top and bottom by that. So in this case, when I multiply top and bottom by 1 minus the square root of 7, in this case I can distribute the 2, giving us 2 minus 2 square root of 7. Not much I can do there. When I multiply this out, again, it multiplies out just like up here. Okay, the middle part is going to subtract out. So 1 times 1 gives us 1. 1 times minus square root of 7 gives us minus square root of 7. Square root of 7 times 1 gives us positive square root of 7. And square root of 7 times minus square root of 7 give us a square root of 7 times 7, or 49. The square root of 49, perfect square, gives us the 7. So we have 1 minus 7 in the denominator. So that gets rid of the square root in the denominator. And so we can simplify this a little bit further if we need to. You know, we could Some people would say, okay, you can stop there. Others would say, okay, well, you know, you have a common factor of 2 here. Let's draw that out. Let's cancel it with a 6. Another way to, I suppose, simplify this is to take the 2 divided by minus 6, like we did here, and the minus 2 square root of 7 divided by minus 6, like we did here, and then reduce each one of these individually. So 2 over minus 6 is minus 1/3, and minus 2 square root of 7 over minus 6 is positive 7 over 3. And you can see we do the same thing with 6, 7, and 8. Let's drop down to 7, because 7 has a variable in it. Okay? And so we start out with 3 minus square root of 5 and 7 minus square root of 3x. So since it's minus, the conjugate would be plus. So we'd have 7 plus square root of 3x. We're going to multiply top and bottom by. So we're going to distribute this out in the top. That gives us a 21 from the 3 times 7. 3 square root of 3x comes from the 3 times square root of 3 square root of 3x. So, the minus 7 square root of 5 comes from minus square root of 5 times 7. And this minus 15x, that comes from minus square root of 5 times minus square root of 3x. I can multiply the 5 and 3 together underneath the square root and write it as 15x under the square root. Down here, okay, multiplying this out, you're going to find that it drops out. Okay. So why don't you experiment around a little bit with these and see what you come up with and see how it goes. Hopefully this helps you out a little bit, and we will look at next time, we'll have a video on exponents that are rational and how they relate with radicals. Until then, have a good day.